We start when we don't enlist this as a generalization and a tirade from me. I can't stand personal and not you. I can't stand sometimes walking by some of these things. You go in, practice 3-4 minutes going, people, like you're in a circus. All of these. We are so calm and orderly. Let's make sure when we come in every day, you come in, grab your seat. We have stuff for you to pick up. It'll be over on the side here. Most days you have an assessment, not all of them. We're going to start off with one thing and then handle another. The first is, some of you have been mapping it out. I think, if I remember correctly, we have, today's day 4, I think day 5 is our last day of the unit. Now, most units will not have a review day. Let's make sure that we understand that fully. Most units will not have a review day. So we'll summarize everything, and when people go, this is my favorite one, they go, well, what is on the test? I gave you a 20, 30 page right on the button summary of what's on the test. If you're able to answer these questions in their entirety, terrific. You have to go through, and that's the other thing. With this sliding and falling off schedule, I personally struggle with remembering who's having their test when. So I'll say this. Today we do day 4. Next class is day 5. Day 6 is going to be a little bit of review. We may even pre-start the next unit. Then the next day after that is going to be when you're examining. So our schedule is we got one more day. Then we're going to have a review day and then the test. So keep that in mind. Your test's another thing that we're going to encounter that may be different, and we said it previously. Your tests are going to be, by and large, split 50-50. Half of the exam will be calculator, and half will be no calculator. So you will be finishing up a calculator-free page, handing that in to get the second one. If you get stuck in a quagmire on one page, that means you get stuck on that page, and just because you didn't finish, you don't get your head back or whatever. Your exam obviously isn't sort of your Super Bowl of math every day. So understand that you've got to make sure that you're ready for it. And the one thing to understand too, I hate personally when people come up to me and tell me you're a bad test taker. It doesn't exist. It just means that you're not, or when people say this, like right now, I would be nervous, right, if I had to walk on a tightrope above Niagara Falls. I'd be kind of nervous. Why? Because I didn't prepare for it. I know what I was doing and feel a lot better if, let's say I had a month, 2 months, maybe not Niagara Falls, but maybe a month or 2 months to go through and prepare for it. Your body gets nervous. Your brain knows when you don't know something as well as you think you do. That's what causes the nerves to happen. So we're going to make sure we get in as many practice reps as you need to in order to be successful. We simulate testing conditions in here constantly. And it's so funny how in the first day you had 4 questions to do. You needed 8 minutes to go through and do them. They were questions from freshman algebra. Now we are up to 8 questions the last time that we met, and you had 6 minutes to get them done. So if you train yourself, you do get profoundly good at taking tests. You don't get nervous, and we'll train you again. And so what if you do bad on a test? Does it mean you're a bad person on the inside? No. All of a sudden you're morally corrupt, some sort of convict because you didn't do well, a social degenerate. Please, you didn't do well on a test. It happens to everyone. It's what life is. You're not going to be excellent at everything all of the time. Now, so some of us just need to show. Now, to make sure that you're as prepared, because again, I will give you as much as you need to be successful. My advice is, and you know yourself better than others, I would go through and finish the questions that we don't get to when we have them in class. That's me personally. I said, you know what? Because again, I'm trying to give you cover as much as we can, in the shortest amount of time as possible, and there's too many things to cover. Plus, you guys are so smart that we don't do, the walk in the park. You add 4. That's not the examples that we do. Again, we did the blades of grass for the other day, right? That's pretty complicated, heavy problem-solving process. That's going to take you a lot. And that's the stuff that we really need to bury ourselves in, not, giving a linear equation like y, 2x plus 4 equals 8, and we're going to spend a month figuring that out. Now, if you want more reps, I'm going to tell you this right now. This sheet that you picked up, if you can do this, you will be successful on the exam. Now, is this sheet mandated to get done? No. If I were you, again, for planning purposes, I would complete this sheet over the next 2 days. As of today, you can answer everything except for question number 6, and after today, you'll be able to answer question number 6. You will find the answers to every one of these questions posted through your Google Classroom. If you go in there, you'll see all of the answers to all of the questions on this sheet found. Somebody in the first class was saying, they read number 4, and they go, well, you didn't teach us this. You're right. I make the false assumption that someone along the way has taught you something. And that's foolish on my part. So what we'll do is, they literally said, I don't know how to answer number 4. Was 4 a discrete function? They said, I don't know what a discrete function is. So we went into Google together and typed in, what is a discrete function? And they weren't set. Now, the 2 choices that you get when you Google it, the top 2 are, when you start typing in what is a DISC, it comes up, what's a discrete function and what's a discrete function in math? Let's narrow our scope down and say, what's a discrete function in math? It literally comes up as like one of those automatic answers from Google where they don't need you to click on something, it tells you what it is. That's what it is. You read the thing and go, oh, okay, that's a discrete function. Oh, I should probably know, maybe make a mental note. That's nothing. I had one kid a year ago, and it was phenomenal, because they came up, they were convinced, they had people tell them that they couldn't do, and I'm not one to tell you what you can and can't do at all. They came up from they came up from 10 Regents to 11 Enriched, which is what you're in now. And they sat there, and they had all these people telling them no. And I love this, like, talk about sticking it to the man. They went through, and they kept a notepad, like a little steno notebook, literally all class long. And if I said something that they didn't know, like let's say I said discrete function, and everyone else knew it, they went through and wrote it out, and then went home and looked it up every day. And I went and I had that book that they went through and did. I went through and photocopied it, and I give it now to my kids that go through and take college algebra at U of R and at Stanford. I give it to my students. I say, this is what somebody did. This is phenomenal. You have to have that level of wanting to succeed. If you're looking for an excuse, you'll always find it. And then I love when people embrace. That's why I love even those of you who were problem solvers the other day, and we were sitting here discussing the different ways to get the answers to that grass question. I mean, that required a lot of intellectual perseverance. That was very, very good for all of them that got at or around that value. And just to try makes you better. Now, as you notice today, we didn't have, when you came in, we did not have an assessment. I'm going to try for about 20 weeks, we're going to have these to start with at some point during the week. And it's a function of the week. So go over to that yellow sheet. So again, that green sheet is, that white sheet is independent practice. Where can you find the answers? Google. Where can you find out what a discrete function is? Google. What's the only thing smarter than me? Google. Nothing. So that's the correct answer. Now, what we left off with is this. So you all should have this out on your desk. We're going to pick a different function every week. And we're talking about what's called a parent function, meaning if you know this function, every other function is based off of some manipulation from geometry on this function. Now, to start off with, it's going to be week 1, and we're going to do one of the 2 foundational functions, which is the identity function y is equal to x. So we'll go through and do the identity function y is equal to x. Now, on the right-hand side, we're going to list out a table of values. And you don't need a calculator to do these out. We'll start off and let's say -5, -4, -3, and so on. So looking at what's there, I see this, and now once I'm to this point, I want to go through and figure out what my y's are. Well, understand that the y values are predicated or based on the input values. So going through and doing this, I would say if I know my x value is negative 5, my y value would be what? Hands up, please, if you can tell me. Look at the relation. Yeah. So my y value would be negative 5. I now have an ordered pair in this relation that I can plot. We don't know whether or not it's a function just yet. Now, we would go through. Negative 4 is going to give you a negative 4. All I'm doing is plugging in the x to get the y. It's called the identity function because when you plug in an input, you get the output. So I would go through and plot all of these out. Now, let's be very clear, too. Some of you have gotten by with lax expectations before. Understand, if there is space to put the point and the point can be plotted, it needs to be plotted. So you will be giving 20 dots as you go across. And then you should ideally use some form of straight edge to go through and connect all of those dots. So on your paper, there should be 20 dots going across. So it's going to look something like that. And let's make them as nice and neat as we can. If you have a straight edge, use them. Use something nice and flat, maybe an old agenda or something like that. Now, let's answer some of these questions. Based on what we have, hands up please if you can tell me what the domain of this identity function is in interval notation. Take a look at this. The domain is the inputs that you use to get the output. These should be coming quicker and quicker. What do you want to say, please? That's outstanding. How about the range on this? Hands up, please, if you can tell me what your range would be. Now, the next thing up that we're going to have to do, this is a pre-calc topic, but we're going to get you started on it now. It's basic math, and just because it's a big topic doesn't mean we're going to avoid it. Looking at this, we're going to start off with we are this guy right here. The other classes decided to call him function point. So you are going to place yourself in the position of being function Frank right now. You can only move from left to right. A function is increasing if, as Frank moves along your graph, the next step he takes is higher up. You are decreasing if Frank's next step is down. You are constant if Frank's next step is straight across in front of him. Now let's ask, and Frank again can only move from the left to the right. He can't go the other way. When is this function increasing? From where to where? Over what interval could we say that Frank's increasing, meaning the next step he takes is going to be higher up? Perfect. So as we go, it would be from negative infinity over to positive infinity. Now the other ones we have to address as well. Hands up please if you can tell me when Frank's trip is going to result in a decreasing interval. As I move from left to right, if I'm Frank, when am I decreasing? Never. There's no decreasing interval, and so we'll say none. And when is Frank constant? Never. Now let's deal with the next piece that we can answer, which is the f of x, which, by the way, just so you know, f of x is replaceable with a y value or an output value. It's just using function notation. Hands up, please, if you can tell me which x's is the f of x or y value greater than 0? Where is the y value for what x's am I at if my output or range or y value is greater than 0. I've got 1, 2 of us, 3. Give it an attempt. What do we think that could be? Yeah, we got 4 of us that can piece things together. When is the y values on this greater than 0? So what would that be in interval notation? Terrific. The function is greater than 0 when the x's are bigger than 0. Let's, do you have a question? No, because think about that right now. What if you're at 0.1? What would your output value be? 0.1, is that greater than 0? Okay. That's why we have the open circle there. So immediately adjacent to that 90 degree, or sorry, immediately adjacent to that 0, we're above. How about where we are less than 0? For what values would that be? When is this function equal to 0? Hands up, please.
Bracket 0.
Perfect. This is the tough one. You could say x equals 0 or just a bracket. That's a single value of 0. Or you could also give out. Now, the zeros of the function. Some of you struggled with this, and I don't know why, but we will rectify it now. The zeros are the same as the x-intercepts, and in order to find them algebraically, you don't say use your eyes. You need to go through and look and show it out algebraically. To find the x-intercept, you go through and set the y equal to 0. So my equation to start was y is equal to x. Where is the x-intercept? Well, I replaced the y value with a 0. So 0 equals x, or x equals 0. Where does this cross the x-intercept, or where does this cross the x-axis, or what are the x-intercept or intercepts? And we would say the ordered pair is 0, 0. Sometimes you need to give it as an ordered pair. Sometimes you give it as an x equals value. I don't want to say they're interchangeable, because sometimes I can't remember one of the two of them. The Regents mandates that you give it as a ordered pair. Look at our next piece where it's talking about maximums and minimums. Looking at this graph, who can tell me what the maximum value this graph will give is going to be? Process what's there. Maximum value is the highest y.
Positive infinity.
Now, if that's the case, is positive infinity a value? No, infinities are ideas, so we're going to say none. Because it does go to positive infinity, you give this calculus notation out, or calculus language. We say it's unbounded above. How about our minimums? We would go, why did you say none? What's the reason? Use calculus language and math appropriate language. You're right, it goes to negative infinity. There you go. So we would say none because this is unbounded below. That means it doesn't have a cap on it above or below. Questions on that? Today we're learning how to fill this box in, so we don't need to be overly concerned with what our inverse or our asymptotes are. You haven't done this yet. We'll get to it later. We did talk last time we had class about an onto function. Does anybody remember what an onto function is? We discussed it last time. Can we give it a try? You look like you had a thought. What were you thinking? The straight line, I'll say this. I'll give an example. A straight line, because that was the example we used last time. This function is onto. A parabola is not. Do you now remember why? No? Give it a try. That actually goes to what a one-to-one function is, not onto.
Does passing both the vertical and horizontal line function?
No. That's for the other piece. What does a line use that a parabola will not?
Uses all the y values.
An onto function uses every available y value. Does this graph use every available output value? So is it onto? Yes, because let's say this, all possible range values are used. I don't even know if the read still tests on that, but in any case you need to, it's a good thing to know. Now the next thing is a one-to-one function. A line is one-to-one, a parabola is not. That means this is going to be a yes, it's one-to-one, because this one passes the vertical line test and the horizontal line test. That means every output that it gives is unique. That's what you were touching on before. If you draw a parabola and go side to side, multiple x's give you the same y. If that happens, that's not the case. Now, we can't fill this last one, and again, this is what's called end behavior. You need this for pre-calculus and beyond. But we'll do it again now, because it takes 2 seconds to wrap your head around. As x goes to positive infinity, what are the function values going to, or the y values? Think about that. Positive infinity is way over on the right. As the x goes to positive infinity, what are the function values going to? And what's happening in this example is we go to the left out to negative infinity, what are the function values going to? There you go. So we can't answer that because that's stuff dealing with trig graphs. So positive infinity and negative infinity. That means it's rising, unbounded above, unbounded below. It's looking at what that overall behavior is going to be. Questions on that? All right, now, there's another thing that we need you all to do. I think we left off on page 19, is that right? Have your notes out, please, to where we left off before. We got through some, we didn't get through everything yet. We're on 18, sorry. Have your notes out and open to page 18. In general, once we finish your assessment, you need to take your notes out. And again, some of us I'm not going to tell you how to live your life, but if it were me, I would make sure that I had one heck of a big binder for this class. Because you see how much paper I've given you, and this is week 2. Now, what we're talking about today are inverse operations. And what I need you to do is, let's do this to start. Take this, please. Turn this note packet maybe on its side like this. These 4 things I need you to go through and copy down. We'll give you a minute. Just copy them down to start. There's 4 things that you need to make sure that you know. I don't know if it's possible to do more to indicate the significance of it, because I'm not allowed to have actual firecrackers in here. These 3 to 4 concepts are so imperative for you to know. And when you get stuck, you just can go back to this list every time and answer the question. If you're asked to find the inverse of a point, which is just a bunch of x comma y's, you switch the coordinates. So the point 2, 1 is going to have the point, or on the inverse would be the point 1, 2. If the original contains the point 5, 0, the inverse would contain the point 0, 5. It's that easy. You just switch the x and y if you're given a bunch of discrete points or a relation. The next thing that you have to go through and do is look at what happens if you're given a graph. You're going to reflect it over the line y equals x. Now, earlier today, you're lucky I'm sort of here, I almost had a mild aneurysm, which was when a blood vessel in your brain explodes. Why? Because someone said this. How are we supposed to know what the line y equals x looks like? So, I'll give you a hint. We just spent about 10 minutes talking about the line y equals x. It's not unreasonable for me to expect you to know what that looks like. You're going to reflect it over it, which is a geometry thing. If you're given an equation, you switch the x and y in the equation. Make sure it's in y equals form first, which means sometimes we pop it out of function notation. We switch the x and the y and then solve for y. And then the last one up is, if the original is 1 to 1, meaning it passes the vertical line test and the horizontal line test, without finding what the inverse is, you can determine whether or not the inverse will be a function, which means it's going to pass the vertical line test. You can make this conclusion without doing any of the work to find the inverse. So the original needs to be 1 to 1 for the inverse of it to be a function or pass the vertical line test. These 4 things we're going to be referencing, in particular when we start asking you questions. Some of you will sit there and stare and go, has he mentioned this before? To find the inverse of a point, you switch the x and the y. To find the inverse on a graph, you reflect it over the line y equals x. And the inverse of an equation, you switch x and y and solve for y. That's it. Those are the 4 things that you need to know. Now, take a look, please. We left off on your homework ones. Another copy. All right. Inverse operations, they undo each other. The inverse operation of addition is subtraction. The inverse operation of squaring an input is to take its square root. The notation is f inverse of x. That's what this means. So to begin, if putting on the sock is the original function, taking it off would be the inverse function. Notice you're left back with the original when you take the inverse of the answer you got before. Over here, if my function is telling me to add 2, what would my inverse function have me do? Hands up, please, if you can answer that. Yep. Subtract 2. Now, as we go forward, I even disregard this piece here. Now, who can tell me 1 point? If that's the original, who can tell me 1 point that's on the inverse? 2 people? 3? Did we ruin someone's day yet? No. Okay, get ready. Let's see. Sam, what do you say? What's 1 point that's going to be on the inverse? Take any of those 3 points. How do you figure out what the inverse is? The inverse is going to contain the point 2, 1. What's another point, Rebecca, that would be on the inverse? And the next point, Michael, what do you say?
Negative 1, 3.
Now, a set of ordered pairs, if the original function has a set of ordered pairs, then the inverse is found by just going through and switching the x and the y. Now let's make it broader than that. if we know what the domain of the function is, what would that be in the inverse? Hands up, please, if you can tell me. You know the domain of the function, what do you know about the inverse? Hands up, please, if you can tell me what that would be. You know the domain of the function, what do you know about the inverse? You know the range of the inverse. And if you know the range of the original function, you know the domain of the inverse. Because again, all you're doing is transposing the x and the y. And you can do that, that's easy. It's very awkward in the beginning to take that first step. You can get there. Now, this is one way to view what the inverse of a function does. When I'm doing this out, and hopefully this builds on your understanding of the order of operations when you're evaluating out an expression. If this is my function, I'm going to pick an x value. And in order to evaluate it out, the first thing I do is multiply it by 2 and then subtract by 5. Keeping in mind what the inverse means to do. If I start off by multiplying by 2 and then subtracting 5, who can tell me what you think you would do to find the inverse? Careful. You're on the right track, I got it.
Divide by 2 and add
Careful.
Add 5 and then divide by 2.
Do the opposite operations in the opposite order. So we'd start off by adding the 5, and then we would go through and divide by 2. That's terrific. So what would that look like as an equation? I'm taking my input, adding 5, and to that answer, I'm dividing by 2. So building up what the inverse equation would be, that's what it would look like. So to test this out, first thing that we're going to do is plug in an 8. So Jordan, what are you going to do if I plug in an 8 into the original function?
So you would do 2 times 8,
Which is?
16,
And then?
minus 5, which is 11.
Okay, now let's test out the inverse, or plug 11 into the inverse. So what would you do first to evaluate out the inverse at 11?
That would give you 6. You would add it to 5, that would
Okay.
give you 16. Then you divide by 2, that would give you 8.
Perfect. Questions on that? Now, here's our equation. Hands up, please, when you can tell me what the first step is to find the inverse of an equation. We literally said that there's going to be people who don't know this. We've written it down already. It's already on your papers. It's already on your papers. What did you list out, loves, as your first step on to figure out the inverse? Now, are they going to know? You have faith? All right, Gerard, what's your first step? What'd you write down? Okay, so what's the equation going to look like when you switch the x and the y? Nope. Switch the x and the y. Make sure it's in y equals notation, and then we do that. What's the next thing that we would go through and do? Jake, we switch the x and the y. What's the second step to go through and determine the inverse? What did you write down? You switch the x and y, and then what do you do? Where were your big 3 for week 4? All right, there you go. For an equation, we switched our x and y, and then what's next?
And solve that.
4? Good. So if you want to get the y alone, what would you do? No? Subtract what? Yeah. X minus 7 is now equal to 2y to the third. Hammy, what would you do next? To get the y by itself? Hang on. Just look at this right here. You want to get the y alone. So what would you do? Divide both sides by 2, so I've got x minus 7 over 2 is equal to y to the third. Mandy, what would you do next? Yep. take the third root or cube root. Now, just so you know, this number on the outside, if it's not written in, you presuppose that it's 2. If it is written in, it's called an index value. So the cube root has an index of 3. When you list this out, there's 2 ways you would give your final answer. I would say, I got the basic algebra is y is equal to x minus 7 over 2. But this isn't just any y equals. This is a special y equals. How does the y relate to the original? Well, it's y inverse. Now, most of the time you will be going through and using some form of function notation if and only if the original uses function notation. Otherwise, you say y inverse would be equal to. Questions on that? Let's bounce ahead. And again, there's 3 things that you need to know. How do you take the inverse of a point? Hands up, please, if you remember that. We've got 1, 2 of you so far, 3. What do you have to do to take the inverse of a point? Terrific. Switch the x and the y. Who can tell me, please, how we go about taking the inverse of a graph? We wrote it down. Reflect over the line y equals x. And then the third piece is, how do we take the inverse of an equation? Who remembers that? Now, what if the function is given out as a graph? Well, we're given as a graph. How do we take the inverse of that? The first thing that I would do is sketch out the line y is equal to x. So you get something that looks like this. You get y is equal to x. That's what that line looks like. Now, there's multiple ways that you can go about doing this, but you should be able to see there's 3, and did we go over what a lattice point is? Crosses at exact value. There's 3 lattice points. What I want you all to do right now is, there's 3 lattice points on the original f of x. One here, here, and here. Go through right now, please, and label the coordinates on that, because I was a little bit taken aback by how, especially on the Cartesian plane that you've been working with for so long, we still struggle with giving out what the x comma y is going to be, and I hope that we're better than that. So, Spencer, what do you go through and say is one of the coordinates on the f of x? Okay, so we've got the point -1, 0. What's another one? And? Okay, now, who can tell me one point that's going to be on the inverse? Hands up, please, if you can tell me that. Because also this gets real, real easy. Yeah. Now, I'm going to go to 0, go over 0, go down 1. Here's one thing, too. They get so obsessed with taking the fun and, I guess, the logic out of geometry. When I'm looking at this, I don't need to memorize the formula really to see what the inverse is. When this function looks at itself in the mirror of this line, this has to go perpendicular to this. So what are you going to do? If I go half a square this way, I'd have to go half a square this way. In this case, I go 1 diagonal length here. Where's the other point going to be then? 1 more diagonal. This one here, the perpendicular is 1.5, so I go a half and then 1. I don't care how you get it, but you do need to get it. You have to do what works for you. And that's why when they're doing all of this with geometry, there's a certain aspect of just common sense and spatial reasoning to it. So this, as an ordered pair, would be the point 0, -1. This would be the point 2, 0. And this would be the point 4, 1. You're going to label this as f inverse of x. What did we do to go from the original to the inverse? Well, you reflected it over the line y equals x. Is the original f of x a function? Giacomo, what do you say? Yeah. Is the inverse a function? Looking at what's there. Caleb, what do you say?
Yes.
By the way, we could say this because it passes the vertical line test. Now, I could have answered B, or this second question, without doing and finding the inverse. How could I know whether or not the inverse is a function without finding what the inverse is? Do you remember? I could say, but you just described taking the reflection, or determining the inverse. I could have answered whether or not the inverse is a function with before I put the y equals x on it. You know why? Before I did that, you're going too far.
If your function passes the vertical line,
Close. You lopped off one little thing.
If the original function passes the vertical line test and horizontal line test.
There you go. I could say this, and maybe we'll do it in the future. Yes? Now, you could say either of those is adequate. This is the low-level definition. If it passes the vertical line test and the horizontal line test, if the original is 1-to-1, then the inverse is a function, and the things that you all described, don't misconstrue it. The things that you all described doing will lead you to the inverse, and they are absolutely right. But you could have known that without doing those steps that you were taking. Just looking at the original. Again, is a parabola going to have an inverse that's a function? And I'm going to say, we're going to argue in just a second, you can make it so. Let's see. Yeah, remember every function has an inverse, therefore, every relation has an inverse, so every function has an inverse, but not every inverse has not every inverse is a function. We've stated it about 46 times so far. Who can give me an example of a function whose inverse is not a function? What's an example of a graph where the original is a function and the inverse won't be a function? Nope. The inverse of y equals x is going to be y equals x. It's going to be a function. Yeah.
Any horizontal lines?
No. No. Quadratic? Yes, quadratic. Now, here's what we were talking about, and we're going to fix something so we don't get sort of stuck and you think that you've hit a roadblock that can't be solved. So here's an example of a quadratic. Now, looking at that graph, if that's my parent graph, is this a function? Is it 1-to-1? Fails the horizontal line test. So the inverse of this won't be a function. And if you want to see how we would go about taking the inverse of this, I would go through and, oh, hang on. This, remember, it's got to be reflected over the line y equals x. So when you do this, your inverse would look something like this, going to the side, because this is the reflection over the diagonal y equals x. Is this graph right here a function? No. What we can do is this. I can narrow my scope or only look at an area of this graph that is 1-to-1. How can I, if I were going to make a window, so I only saw this as a 1-to-1 function, where would I be looking? From where to where could I restrict my domain to make this be a 1-to-1 function? What do you want to say? Because there's more than one right answer. Gave them both. I could restrict this down. What if my window was looking at, what if my window looked like this? So I'm going to look from here to here. If that's where I'm looking, now this was the negative x, and she said the positive ones first. Is this portion of a quadratic 1-to-1? So if you narrow your domain down or put what's called a domain restriction, it's 1-to-1 then. What about if I look over here and I restrict it down to be the positive axis? That piece would then be 1-to-1. So if you restrict your domain down to a smaller window, you can in fact go through and determine what the inverse is going to be and have that inverse come out to be a function. Now, Let's start off with some. Now, before I answer the first question, we'll answer the second one so you can get used to doing this. Think about, do not graph this, and you're not doing anything other than writing down what the equation is. We're going to answer the second part first. Is the inverse of this a function? Hands up, please, when you can tell me the answer to that. Think about what that graph looks like. Is the inverse to this going to be a function? And what is your appropriate justification? What do you want to say?
Yes, because that's always equation.
Close. I'm going to say your answer isn't tight enough. We would go through and say yes. Because what? 2 people? We can do better. 4, 5? Come on. Come on. What do you want to say?
Because 2x times 2x in vertical line and horizontal line.
If you were to say it even shorter than that, what's that called? Past the vertical line and horizontal line. What? No. 1-to-1 function. Yes, the inverse is a function because f of x is 1-to-1. Now, let's figure out what our inverse is going to be. So to start this off, I have, this is my y equals, f of x and y equals are the same thing. So once I figured out what my equation is going to be, how would I go about determining what the inverse is? McKenna, what would you do next?
You would switch the x and the y.
Okay, so what is it going to look like when you write it out?
X equals 3y minus 2.
So after you switch the x and the y, Felix, what's the next step? So what would you do to make that happen? No. Add 2 to both sides. Divide by 3. Now, I would list this out now as f inverse of x, not y inverse, because look at the original. I can answer the b half of this before I answer what the inverse itself is. Looking at what's there, look at the original function. Hands up, please, when you can answer the second of our 2 questions. We've got 2 people, 3. Think about the original. You don't need to look at a graph of this. Look at what that function is. Let's make some conclusions based off of the type of equation that we're given to start. Ben, what do you say? What type of graph is f of x going to look like? No, look at that. What type of graph is f of x going to look like? Who can tell me, please, what that's going to look like when we graph it out? Quadratic. So, it's going to look like a parabola. Is the inverse of that function going to be what? Could we restrict the domain to make it such? And the answer would be yes. We're not asked to do that. First thing up in finding out the inverse, I'd swap out my f of x and make it a y equal. So y is equal to. Now, what would we do next from here? Lily, what would you do to find your inverse?
Switch the x and the y.
So what would it look like?
Equals y minus 2.
Now I need to go through and determine what my inverse is going to look like, or sorry, to isolate the y. What needs to happen in order to solve this for y? Eva, what do you say? What's that? Careful. And you got the right idea, you said the wrong thing. It's squared right now. Square rooted. Now, this is another piece where you guys are going to encounter a little bit of an issue because they don't go over fundamentals of algebra with you. This, as it's written right now, is incorrect. You can't get to that 7 until you deal with what's furthest on the outside first. You have to undo the furthest operation first. Now, if I were to take or ask myself, what times itself gives me 25, and you only said 5, you would be wrong. If you are taking the square root of a number, you need to accommodate for the positive and the negative. So our answer does as well. We need to now solve this out for y, so I would go through and say plus or minus root x plus 7 is equal to y. How many different inverse functions is this in reality? There would be 2 there. One's with the positive, root x plus 7, and the other one's the negative root x plus 7. I'd say f inverse of x is equal to, and I'll actually put this the other way because it works a little bit easier for you to see the separation. One 7 plus root x, 1 7 minus it, or the other way around, that's fine as well. Questions on that? Take a look at 5a. For the inverse of a function to be a function, the function must be 1 to 1. It's 1 to 1 if each y value has only one x value associated. So take a look at 5a. And looking at what's there, Mike, is the original function 1 to 1? Yes or no?
Yes.
Now, what would you go through and do for the next piece? Is it going to be, is the function going to have, or is the inverse going to be a function? Let's look at the next one. Is that going to be a function, or is it 1 to 1? Logan? So what do you know about the inverse?
It's not
The inverse exists, it's just going to fail the horizontal line test. Now, we don't have enough time to get through. Well, actually we do. We'll make it quick. If I were to, we won't even answer the second half, you could look at the graph to tell me, here's my original y equals root x plus 3. To find the inverse, I switch them. X is equal to root y plus 3. If I need to solve for y, what's the next step? Not yet. Take care of what's furthest away. Nope. Minus the 3. So we've got x minus 3 is equal to root y. I still need to get that y by itself, so who can tell me what I would do from here? Go ahead. Square both sides. So now I would state my inverse, or y, is equal to the quantity x minus 3 being squared. This is a piece you would have to look at the calculator to figure out. But what's the problem with this? Well, the original, if I were to graph out the original, it would look something like this. If I reflect that over the line y equals x, this is a quadratic. Is the inverse going to be a quadratic? No. It's going to be only part of that. So it would have to be sort of this piece here, which means I only look at the x's. This would be, you'd see this from the graph. This is that x is equal to 3. So we would need to go through and say that x needs to be greater than or equal to 3. That's when we talk about narrowing our window. Now, your homework is to go through and finish off. You have a calendar questions. You have those to go through and get done. Now, I'll tell you why I'm not collecting the homework today. Because as I went through the cafeteria and had lunch duty the other day, I saw a wonderful thing. 2 of my angels sitting there copying homework from each other. Wonderful. You ruined it for everybody. If there's people copying it, well, I don't need you to be a Xerox machine. I've got one at the end of the hall. In fact, next time, if you're smart, give it to that person. I think you can even make photocopies from there. Is that true? You like log in? Right. So then, those people, they're not smart enough to get rid of the name. They're sending the same sheet 400 times. That's fine. Have a great rest of your day, kids. Here, hang on to that. And I'm going to tell you this. Next time, if you know what stuff to send it to my face. Alright, you can roll the leave in there. And then you can go. Okay? And I'll give you 2 or 3 days. Okay? So don't rush. We go over this at the beginning of class. Okay? This is a supplemental one. No. The answer is supposed to be labeled faster. This is an actual review. We always did that yellow sheet when we started class and just carried it. You're already, you got a leg up on a lot. Okay? Was it difficult? It'll play a second. Okay? Check the answers on the computer. The inverse of a y equals, would not be a function because it fails the horizontal line. Well, no, the original, if it's a y equals line, if it's a y equals line, that's not 1 to 1. So the inverse exists, which would be that vertical line you're talking about, but it's not a function.
Okay, yeah, because I when you asked what the inverses of what would be function.
Oh, I'm sorry. Then I misheard you. I'm sorry.
Okay. I was like, wait, what? What?
We did that together. Just watch the video. Okay? And you'll be able to see, I think it took, how long did we spend on that? 10 minutes-ish? Okay? All right, yes. First homework? All right, I'll take that one. Thank you very much. Okay, is that the, I don't know if it's the review day or the test day. It all depends on the sequence of our days. Like we said, we have one more day of the unit, then review, and then test. So if that's when it falls, yes. Okay. So what's this today, Wednesday? Tuesday? All right. So if that's the case, if you do miss a test, it'll be down waiting for you in a minute. Okay?
Okay, thank you.
Yep.
You wanted me to have you go to the consultant.
Oh, yes. And we'll go through and handle that right now. Thank you.